Good morning, students. Chapter 4, Moving Charges and Magnetism. Yes, in last lecture we have discussed about magnetic moment of electron revolving in orbit. Okay, yes. Now today in this lecture we will discuss some questions. See, here it is. Exercise 4.20. Uniform magnetic field B is equal to 0.75 is acting in some region. In the same region, uniform electric field is also present. Okay, a narrow beam of charged particles are accelerated by 15 kilovolt, enter perpendicular to both fields. What is magnetic field? B 0.75 Tesla. Yes. What is electric field? 9 into 10 raised to 5 volt per meter. Charged particles are accelerated by 15 kilovolt, enter perpendicular to both fields. Perpendicular to both fields. Clear? Then your question is, make a simple guess as to what the beam contains. What beam contains means, is this beam is made up of protons, of electrons, of alpha particles, of which particles? Yes, you have to find this. See how to find this. First of all, this a narrow beam of charged particles are accelerated by 15 kilovolt. Okay, they are accelerated. They are accelerated by 15 kilovolt. So first of all, I will find speed of charged particles. How to find? See, with the help of this equation, we know that QV is equal to half mv square. Yes or no? Yes or no? Yes. QV is equal to, it is half mv square. QV is equal to half mv square. We know this equation. Okay. Yes. You are given B and E. There is also one relation. See. We know that V is equal to, it is E upon B. We know that B is equal to, it is E upon B. So yes, first of all we will find B is equal to, it is E upon B. See, V, speed of electron. E, what is value of E? 9 into 10 raised to 5. What is value of B? It is 0.75. Then what is value of speed? V is equal to, it is 12 into 10 raised to 5 meter per second. 12 into 10 raised to 5 meter per second. Now put this value of V in this equation, and from this equation see. Now what is actual equation? See, beam. Okay, yes, in this beam, charged particles are moving. There is perpendicular or cross electric field and magnetic field. Enters it normally. Okay, beam undeflected. See, beam is moving undeflected. Remember theory of velocity selector. When beam moves undeflected, when charged particles moves undeflected, in this situation, speed of particle V is equal to, it is E upon V. V is equal to, it is E upon V. So first of all we have find V. V is equal to 12 into 10 raised to 5 meter per second. Clear about this? Clear about this? Now, accelerated by 15 kilovolt means QV is equal to half mv square. QV is equal to half mv square. Clear about this? So now, from this QV is equal to half mv square, make Q upon m as a subject. Q upon m as subject. If we make Q upon m as subject, then we will get it is V square upon 2. We will get V square upon 2. Q upon m. Chalo, what is value of V? It is 12 into 10 raised to 5 full square divided by 2. V potential, yes, it is 15 kilowatts. So yes, it is 15 into 10 raised to 3. Clear about this? It is 15 into 10 raised to. Okay. So yes, 12 into 12, 144 divided by 30. You will get your answer. It is 4.8 into 5 into 10. 10 minus 3 is 7. So yes, it is 10 raised to 7. So it is Q upon M. What is its unit? Its unit is coulomb per kg. Its unit is coulomb per kg. Now, how to identify which charge particles are moving? Which charge particles are moving? See, this Q upon M, it is called specific charge. It is called specific charge. Okay, specific charge is 4.8 into 10 to 7 coulomb per kg. What you have to do? Yes, we have to assume. First of all, take proton for example. For proton. What is charge of proton? What is charge of proton? 1.6 into 10 raised to minus 19 coulomb. What is mass of proton? Yes, it is 2.7 into 10 raised to minus 26. 1.6 into 10 raised to minus 27 kg. Yes or no? Find ratio for charge to mass for proton. If your answer is similar to this answer, then charge particles are proton. Yes or no? Yes or no? Yes. Similarly, find Q upon M ratio for electron. Find Q upon M ratio for deuterium. Find Q upon M ratio for tritium. Find Q upon M ratio for such particles. Okay. And yes, there is one another question. Is your answer unique or not? Unique or not? You have to find ratio of some charges, some particles, Q upon M, Q upon M, Q upon M, for proton, for electron, for deuteron, for tritium, for such particles. Yes, you have to find, ratio for proton, electron, He plus, okay, for such particles, you have to find ratios. Clear? And yes, whatever answer matches, it is your clear about this. Next question is exercise 4.20. See, starting motor of a car is connected with two wires. So obviously, in one wire current is entering and from another wire current is moving outside. Okay, so yes, two wires. Okay, 70 centimeter long and 1.5 centimeter apart. They are D is equal to 1.5 centimeter apart. What is question? What is force per unit length between these two wires? Also, is this force attractive or repulsive? So yes, we know one equation. F is equal to mu 0 I1 I2 L upon it is 2 pi d. Yes or no? But you have to find force per unit length. Means force per unit length is equal to mu 0. Another thing, see, these wires are connected with positive and negative terminals. So if current I is entering, then obviously current I is leaving. Clear about this? Then yes, from both wires, magnitude of current is same. Divided by it is 2 pi. Yes, mu 0, 4 pi into 10 raised to minus 7, I 300 given 2 pi capacitance, and D that is 1.5 centimeter. You have to convert in meter. You can easily calculate this answer. Another question, attractive or repulsive? Remember, when from two parallel wires currents are flowing in same direction, there is attractive force, but when they are in opposite direction, there is repulsive force. Yes, here two currents are moving in opposite direction, so there is repulsive force. Clear about this? So yes, this question you have to find. You have to just put value 4 pi into 10 raised to minus 7, I 300, 2 pi as it is, and D 1.5 centimeter means 1.5 into 10 raised to minus 2. Clear about this? Now next question. Exercise 4.21. A conducting rod of length 0.45 meter length and mass 60 gram is suspended with the help of two wires like this. See, if it is one rod like this, it is suspended by two wires. Okay, suspended by two wires. Carrying current 5 amperes. Suppose that current I is flowing in this direction. I is equal to 5 ampere. What is question A? What is magnetic field? What is magnetic field in this region such that tension in wire is 0? Now, in this wire, this is wire, it is wire and it is rod. So when tension in wire is 0, it means resultant force acting on this rod is 0. Resultant force acting on this rod is 0. Tension in wire 0. It means tension in wire. Tension in wire is 0. It means resultant force on rod is 0. On rod is 0. Okay, why tension is 0? Because there is no net force in downward direction. If there is some net force in downward direction, then and then there is some tension in this wire. Now net force acting on this wire is 0. It has mass 60 now. Means obviously mg is acting in vertically downward direction. Mg is acting in vertically downward direction. Yes or no? Yes or no? Yes it is. Yes it is. Okay. Now. What is magnetic field? What is magnetic field such that tension in wire is 0? Magnetic field, it is current carrying wire. On current carrying wire, due to magnetic field, force must be acting in upward direction. Must be acting in upward direction. Yes or no? So yes, when force acts in upward direction, it is I. If magnetic field is perpendicular inside. If magnetic field in this region is perpendicular inside. If magnetic field in this region is perpendicular inside. So see, current is flowing in this direction. Magnetic field is inside. Then this thumb comes in upward direction. Means force acting due to magnetic field Fm. It becomes in upward direction. So if B is perpendicular inside. If B is perpendicular inside, then Fn and Mg, they becomes opposite direction. Clear about this? Clear about this? Okay. Now Fm is equal to Mg because tension 0 means resultant force on this rod is 0. So Mg is equal to Fm. Fm is equal to, it is IL cross B. So what is its magnitude? It is Fm is equal to ILB sine 90. From figure it is clear. It is ILB sine 90. Sine 90 it is 1. So it is ILB. So how to write Fm? It is ILB is equal to Mg. You have to find magnetic field. So B is equal to, it is Mg upon IL. You can easily find its value. M 60 down into 10 to minus 3 kg. G, yes you know. I is 5 ampere and L 0.45 meter. So you can easily find what is magnetic field. Clear about this? Clear about this? Again, tension in this wire is 0. It means net force acting on this rod is 0. Mg is always acting in vertically downward direction. So due to magnetic field, force acting must be in vertically upward direction. Fm in this direction. And it is possible when magnetic field is perpendicular inside. Clear about this? Clear about this? Okay. Now, what is second question? Yes, you can calculate this. What is second question? What will be the total tension if direction of current is reversed, keeping magnetic field same? Means see, I will draw the figure again. Rod, wires. Okay, magnetic field be same, means perpendicular inside. Perpendicular inside. Okay. Now current direction is reversed, means current is going now in this direction. Clear about this? Mg is always acting in vertically downward direction. Now what is direction of magnetic force? Current is going in this direction. Magnetic field is inside. The force due to magnetic field on current carrying wire is acting in downward direction. That Fm is acting in downward direction. That Fm is acting in downward direction. Clear about this? Clear about this? So yes, now what is tension in this wire? Tension T in this wire. Tension T in this wire. C is equal to Mg plus Fn is equal to mg plus Fn. So yes, in this situation, tension T is equal to, it is mg plus Fn is equal to, it is mg plus ILB. M given, G given, I given, L given, B given. You can easily find what is value of tension. You can easily find what is value of tension. Clear about this? To see, if you change direction of current, your answer changes. Clear about this? Watch regular videos, students, make notes, solve your doubts and appear for each and every exam. And yes, do like, share and comment